I hope you are doing okay, and in this video I'll solve some questions under SET theory. So these are just some common exam questions. Okay, so after this you should also try to practice some questions. So first start by proving the De Morgan's laws. And the first one, question 1, prove the De Morgan's laws. A union B complement equals A complement intersect B complement. So that's the first one we prove. So A solutions, we are saying we have A union B complement, A union B complement equals to A complement intersect B complement. So we should show that this is equals to that. So what you do, you say, so when answering you have to be writing these statements. So you start, we have to show that, so one, we have to show that what's on the left hand side, A union B complement, is a subset of what is on the right hand side, A complement intersect B complement. So that's the first thing. And A complement, you get now what's on the right hand side, intersect B complement is a subset of A union B complement. So we have to show that what's on the left hand side is the subset of what's on the right hand side, and what's on the right hand side is the subset of what's on the left hand side. By so doing, we would have proven the De Morgan's laws. So that's the first statement, right? Then the second thing, so you start from the left, so you write, you have started from the left hand side. So from the left hand side you have to say let for all x's be members of what you have on the left hand side. So say A union B complement. So there, where there is for all x's, you can also find this symbol like this. That symbol, it's just one and the same, more like an upside letter A, just one and the same. Where there is for all x's there, you can substitute with that symbol. Okay, so let for all x's be members of A union B complement. Then if x is a member of A union B complement, what does this mean? This simply means that, so we can say this implies that x is not a member, so x is not a member of A union B, since it's outside A union B, meaning it's not a member of A union B. Then from there we can say this implies that, so what you should know is that union, if you have a union set, we're using or, then intersection set we'll be using and. So this is the standard way. Union set will be using or, intersection set and. Okay, so we'll say at this point, since we have a union set, to separate them we use or. So say x is not a member of A, or union we change to or x is not a member of B. So you separate them. Then from there, this implies that x, so since x is not a member of A, meaning that x is found where outside A, so say x is a member of A complement, then this O changes to and. So say and x is a member of B complement. Then proceeding, we'll say this also implies that x, so you just have to combine the two now for and using intersection there. So say x therefore is a member of what? A complement intersect B complement. So we have moved from what? Left to right hand side. We have just proven the first statement. So at this point you can even say, therefore, what we started with, which is A union B complement, is a subset of A complement intersect B complement, and you can let this one be your first statement. Okay, then we'll say conversely, meaning we have to prove now from the right hand side. So we'll start with what? Right hand side. So conversely, right hand side. So for the right hand side, you get what you have on the right hand side. Just start it like that rather. So you say let for all x's, so what you have on the right hand side there, that's what you pick. So say let for all x's be members of A complement intersect B complement. So now we are moving from right to left. Okay, so just follow the steps even for this one. So say this will imply that, so we have x being a member of A complement intersect B complement. So for and, let's separate them. Intersection, it's and. So we say x is a member of what? A complement, and that's for intersection. So and x is a member of B complement. We have separated them. Then from there, since x is a member of A complement, what does it mean? So this implies that x is not a member of A, since it's a member of A complement. Then it's not a member of A. Then and changes to or x is not a member of B, since it's a member of B complement. Then at this point, just combine the two. So therefore we'll say x, so just check, we have x being a member of A or x being a member of B. So or, for or we use what? Union. So this means x is not a member of A union B. We have combined them using union. Then if x is not a member of A union B, what does it mean? It implies that x is a member of A union B complement. X is found outside A union B. So we have moved from the right hand side to left hand side. So we have just proven that second statement. At this point, we can even say, therefore, A complement intersect B complement is a subset of A union B complement, and you let that be your second statement. Then to conclude, you say from 1 and 2. From 1 and 2, we conclude that what we are proving, which is A union B complement, is equal to A complement intersect B complement. Even right, hence proven. So that's how you prove the De Morgan's laws. So we have proved the first one, this one. So we have proved the first one. Then we can move on to the second one, A intersect B complement, which is equal to A complement union B complement. Let's move on to the second one. So we are still dealing with question 1b. So for question 1b, we have to prove A intersect B complement being equal to A complement union B complement. So we just do similar things, just like question 1a. So even for this one, you have to write, we have to show that, or to prove that. So we have to show that the first statement, you start with what you have on your left hand side. So we have A intersect B complement. So we have to show that A intersect B complement is a subset of what you have on your right hand side. The subset of A complement union B complement. After that, and 2, we also have to prove that what we have on the right hand side, A complement union B complement, is also a subset of A intersect B complement. So that's the first statement you write. We have to show that 1, A intersect B complement is a subset of A complement union B complement, and 2, A complement union B complement is a subset of A intersect B. So you do that. After that, you start from the left hand side. So from the left hand side, you have to say, let for all x's be members of what you have on your left hand side. Members of what? A intersect B complement, like that. Then at this point, this implies that, so if x is a member of A intersect B complement, what does it mean? It means that x is not a member of A intersect B, since it's what? It's found outside A intersect B. Then from there, this will imply that, so let's separate this. We have intersection. To separate them, we use and. So x is not a member of A, and x is not a member of B. Because of that intersection we use and. Then this will imply that since x is not a member of A, meaning that what? X is a member of A complement, then and changes to O, x is a member of B complement, since x is not a member of B, meaning it's outside, it's found outside B. Therefore we say B complement. Okay, then let's combine them. Since we have O, we combine them using union. So this will mean x is a member of A complement union B complement, like that. Okay, then as you can see, we have moved from left hand side to right hand side. At this point, you can say we have proven the first statement there. So we say therefore we have moved from A intersect B complement. So say intersect B complement is what? Is a subset of A complement union B complement. You say this is your first statement. Then conversely, okay, conversely, right hand side. Now we start from the right hand side. So from the right hand side, what do we have? A complement union B complement. So you just start it one and the same. Let for all x's be members of what? What you have on the right there, A complement union B complement. A complement union B complement. Then we have to separate these. Then how do we separate them? So this will imply that since we have union, we use O. So x is a member of what? A complement, or x is a member of B complement. Okay, then this will imply that since x is a member of A complement, to imply that x is not a member of A, then O changes to and. X is not a member of B, since it's a member of A B complement. Then this will imply that at this point you just combine the two. Since we have and, you combine them using intersection. So to mean that x is not a member of A intersect B, combine them like that. X is not a member of A intersect B. So since X is not a member of A intersect B, what does it mean? To simply mean that X is a member of A intersect B complement. Yes. So that's it for that one. Then from here we can say, therefore, what we started with, A complement union B complement is a subset of A intersect B complement. And you say this is what? Second statement. At this point, you are even almost done, just concluding. So you can say from 1 and 2, we conclude that. So from 1 and 2, we conclude that A intersect B complement is equal to A complement union B complement. From 1 and 2, we conclude that A intersect B complement equals A complement union B complement. You can even say hence proven. So this is how you prove the De Morgan's laws. Make sure you practice how to prove the De Morgan's laws. Okay. Moving on to question 2. So the second question, show that A complement equals to A. So this is simply complement of A complement under the complement laws. So for question 2, we have to show that A complement equals to A. So we are simply showing that the complement of A complement is equal to A itself. So to do this, say, so it's similar to how we prove the De Morgan's laws. Even this one, when you're starting, you say we have to show that. So you start with what you have on your left hand side. A complement is a subset of A. So this is the first thing we are proving. And secondly, we also have to show that A, what you have on the right hand side, is a subset of what you have on your left hand side. So we just have to prove these statements. Okay, then we start now. Left hand side. So from the left hand side, you do the same. Let for all x's be what? Members of A complement, like that. That's the first thing. Then this will imply that, so if X is a member of A complement, meaning that what? X is not a member of A complement. Since it's a member of A complement, meaning X is not a member of A complement. Then if X is not a member of A complement, this will mean what? X is a member of A, like that. So we have moved from left to right. At this point, you can even say, therefore, so we have simply shown the first statement. Therefore, A complement of complement is what? A complement or complement is a subset of A. First statement. That's how you do it. Then we can say conversely right hand side. So we do the same thing for the right hand side. We are starting with A. So you say let for all x's be what? Members of A. Then this will imply that if X is a member of A, we can say X is not a member of what? A complement. And if X is not a member of A complement, simply means that what? X is a member of A complement, like that. If X is not a member of A complement, meaning X is a member of A complement. At this point, we can even say therefore, so meaning we have proven the next statement. A is a subset of A complement. Second statement. From here, we can even say from 1 and 2. From 1 and 2, we conclude. From 1 and 2, we conclude that A complement of complement, so A complement of complement is equals to A, hence shown. Now, that's it for that one. You can see, shown. So that's how you prove the complement of A complement. That's how you do it. You can use any other letter apart from A, but just using the same procedure to prove this one. Okay, so that's it for question 2. Then moving on to question 3. Just delete that. Move on to question 3. Okay, so for question 3, using the associative and distributive properties of union and intersection of sets, show that. So here we are simplifying sets using distributive properties and associative properties. So we have to show that A is equals to A intersect B union A intersect B complement. So let me just write that. We have to show that A is equal to A intersect B union A intersect B complement. So we have to prove this one. When you simplify this, you should get that A. So how do we simplify? So we just use those set laws we talked about. Those set laws are the ones that are used to simplify such sets. So here we have the left hand side and the right hand side. So we are starting from the right hand side. So you write what you have on your right hand side. So that's A intersect B union A intersect B complement. So here, if you check under the distributive laws, you have A intersection. This is what? This is common there. It can be factored out. So we have A intersection like that. So A intersection. Then what will remain? Just remain with B union B complement. What have we used? We have used the distributive laws. So these are distributive laws we have used. Then what is B union B complement? So what is, if you have a set B, like that. So these are simply those same laws are the ones we are using. A, B there, then intersection. Let's say here we have A, B, then C, D there. Okay. So if we have B, set B, which is just B and C, then what is B complement? So B complement is A and D. A and D. Then if you put together B and B complement, what are you getting? So A, B, C, D, and A, B, C, D together, everything give what? Give the union, the universal set. Everything give the universal set. So we have A intersect E there. B union B complement is simply equal to E, or universal set. Okay. Then what is A intersect of E? So remember we said that any set intersection of the universal set is simply that set itself. Therefore, we have simplified and found that A. So that's it for the first one. Then B, let's check what do we have. So we have A union B being equal to A intersect B union A intersect B complement union A complement intersecting B. So we have to simplify this. We have to show that A union B is equals to that. So let's simplify this complex part and we should find A union B when we simplify. Okay, so if you check, we have 1, 2 parts there. A intersect B, A intersect B complement and A complement intersect B. So if you check the first two, these ones, so let's start with the first two. Let's simplify the first two, then you add on that one. So for the first two, if you check, there is A intersection which is common, so we can factor out this one. So we can say A intersection is common like that. When we factor out A intersection, we remain with what? B union B complement. So we remain with B union B complement. Then you just add on what is this side, union A complement intersect B. Okay, then let's continue. Then here, let's check where can we simplify further. Here for B union B complement, so we are getting a set and its complement, finding its union. It's the same, we just proven there, which is A intersect E. So B union B complement gives E. So this is simply A intersect E, and even close it like that. Then union, we have A complement intersect B. A complement intersect B. Then what is A intersect of universal set? So any set intersection of the universal set gives what? That set itself. So it's A union A intersection, A complement intersect B. Then at this point we can use the distributive laws where we multiply A union by A union by B. So if we multiply A union by A, we get A union A complement. Then what's in between there is simply maintained. Then A union by B will get A union B. You do that. Okay. Then what is A union A complement? Similar to B union B complement. So A union A complement simply will give us the universal set. So universal set intersect of A union B. So universal set intersect of any other set gives that same set. So A union B. That's the answer. So A union B, one and the same. Okay, so for this video, that's it. We'll solve more questions. So I just hope you have understood. Make sure you go through. If you are doubting somewhere, just watch the video. You can just watch it several times until you get the concept. Otherwise, I hope you even studied the set laws. That video which I talked about the set laws, I hope you studied them. If you did not, make sure you go through. That's when these questions will be easier for you. So see you in the next video when I'll be solving more questions.